practice a lot of stuff in class, so since we were a little bit behind. Okay, now. You gentlemen have a lot of energy today. Maybe we should play the popcorn game so that we can get some of that energy out. But it needs to be calmed down a little bit for it. Alright. Alright, number 3. What type of average is used to calculate the average atomic mass? Alright, Chris.
Weighted average is used to calculate atomic mass.
Good job. Alright, that was done. You can go ahead and put that away now. Now keep in mind, your periodic table quiz is what day? Ethan. We just went over this. When is it?
Friday.
Friday. So, and Jamie and Quentin, the gentlemen, were also asking as well. Do you need to know it as the idea of what symbol is what element, or do you just need to know what element is what symbol? You know it both ways because the quiz will have both of them on it. So don't just memorize it as Hg means mercury. Also know that mercury has the symbol Hg. So go both directions for it. All right, Chris, which question?
Are we reviewing for the test today or tomorrow?
Talking about the chemistry test or talking about the history test? Chemistry is a little bit further. Chemistry will be next week, either Tuesday or Wednesday. So because of that, I'm not sure quite which day I want it to be on yet. So we'll have to see how fast we move today, and that kind of determines for it. But the periodic table quiz is Friday. So focus studying these because you have to know these will also be on your tests.
Is it on chapter 2 too, or chapter 3 as well, the test?
The test, no. For chemistry, it's just chapters 1 and chapters 2. We're in chapter 2.
Are we going to start with chapter 2?
Yes.
Like page 33 or 30?
Yeah, we're very close. We're almost done. Alright, so let's go ahead and let's I think I started with Ethan last time, so we'll start with Chris this time for it. I'm pretty sure I know you.
No, because yesterday you said the same thing.
Oh, okay.
Because he was like, I think we.
I just always think you start first. Alright, so, this is the game where you're choosing the numbers. I guess gravity kind of. I did remember to move it though, so it is in a different spot.
Oh man.
Yeah. Alright, Ethan. Alright, Mercury has what symbol then?
HG.
That was kind of an obvious one. I didn't use that as an example. That's not fair. Alright.
Wait, what?
What beryllium has what symbol?
BR?
Nope.
BA?
B-E.
B-E. B-E.
19.
Alright. Calcium. Oh, you already just went. You stole.
CA.
Good job. You don't see through the card. I feel like y'all
Let me
can.
see.
I didn't see
Wave
it.
your hand. You can see through the card a little bit.
If you hold it like that, yeah.
Maybe hold some cards behind it.
Yeah, well then I can't see what card I'm holding up. I can just see it. That's probably the reason why I flip it the other direction, so that way I can see like the word on the back. Okay. You got a point.
Number one.
Did you say middle one?
Number one.
Okay.
You had someone get it first, right?
Like one time. But this is now the second time someone has got it on their first guess. So, good job.
Did you know what was that?
Yeah, I remember. You don't have a, but I haven't picked number 1 in a while. So I was like, it'll be safe. Guess not.
Well, I just had a feeling it was there. Oh, well. It's fine.
Gonna move it now.
How much you want to bet
She
on?
moved it to 13.
How much you want to bet on? We'll guess it again on the first time.
If you guess it again the first time, I'm leaving.
Cobalt. Trying to see the word. You don't have to see your card. Cobalt.
C-O.
CO. CO is correct. So CO.
17.
Is your mouse okay?
Did I remember to blank it out whenever I chose it?
Yes.
I did? Okay. Good.
Fine.
Just wanted to make sure. Alright. Rubidium.
Rubidium?
Rubidium.
RP?
Good job.
19.
I think the batteries in my mouse are dying. I just replaced them. Just remember.
Let's say.
Alright. Chlorine.
CO.
Good job. I feel like you're cheating. You're doing good.
18.
Alright. Uranium.
You're right. You are. No. You wait.
Nope.
U.
about something and more noise.
Helium.
AT.
He.
34.
Fluorine.
F.
Yep. Good enough, you.
23.
Argon.
AR.
That's it. You're doing good today.
33.
Carbon.
C.
That is C.
16.
Good job.
That's why you asked if you blanked it out because it was really close.
Yeah, because I was like, did I? I don't remember if I did or not. I was like, okay, I need to make sure I.
Bruh.
Bruh.
Bruh. Bruh. How much one best spot on that number 1 year?
I did pick the exact same spot one time. So for all people.
She moved it to 35.
Alright. Nitrogen.
Man.
Get up.
No, we're all just gonna ask anyone. I've never told them that. Number 35.
Oh, if I guess it.
Alright. What is oxygen?
Oh,
Oh. I
19.
got them pretty much perfect so far. Alright. Radium.
Alright.
That's it.
26.
It's also
Oh, I'm about to say.
I can't change it. It's like programmed into it, and I couldn't figure out how to do it. So it got way too confusing, way too fast. All right, what is zinc?
Z. Zinc. Is it ZI?
Nope.
ZN.
ZN. So write down zinc to make it study a little more. All right.
37.
What was that? 27?
7.
Oh.
So you get another one, you're gonna give him 2?
I said 7.
Because he did change it right as I clicked it. So make sure you are clear. For future, you will be clear. All right, iodine.
I.
Yep.
I mean, I helped you out, basically.
20.
That's 2 of them that are wrong.
Right, that was 21, regret? Just making sure. Alright, arsenic.
AS.
Good job.
I'm remembering that because it asked me.
34.
Fine, 34. Alright, aluminum.
AL.
AO.
31.
It's over there somewhere.
Alright, krypton.
KR.
Good job.
33. Why is it on the completely different
Alright.
side?
I'm not telling you. Alright, neon.
Is it N? Is it N?
Yep.
4.
Alright, nickel.
And
And
3.
magnesium. MG is correct.
24. Code.
Good.
That's 25.
There is no 20. Oh, what did I say?
Now you get, okay, so now you both had 2. Alright, silicon.
Silicon?
Silicon.
SI.
Good job.
Number 8.
One of the scientist units.
Xeon.
We're both about to do it.
Xeon. Is it ZN?
Nope.
Wait, what? Xeon?
Zinc.
Xeon?
Xeon.
Xeon.
Yeah.
X. XE.
Xe. Yeah, it's pronounced with the Z, but it has the X on it, so xenon.
How you spell
Number
it?
20.
Xenon.
20.
Mm. I know. Alright, Chris. Oh, I'm sorry, it's your turn. Copper.
CU.
Get up.
Silicon.
Can you come out of the.
Alright, manganese.
M-N.
Get up.
I would guess it.
Number 11. is it?
Platinum.
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 It doesn't start with a P, does it?
It does.
It is a-
I know it.
Platinum. Say P, yeah.
Yep. Alright.
No,
Is it PT?
wait, I didn't say anything.
Oh, I thought you were guessing. I'm sorry. We'll
Alright.
just null and void it then, since I've already let you guess though. Alright, but PT is correct. Make it up PT. Alright, back to you. PD. What is this one? This one's a hard one.
Acid.
Nope.
Fire.
Nope. Lead. So.
Lead.
Ah,
I'll put these
PB,
back
lead,
to the list.
lead.
The P's are hard. So PB, the students last year memorized it as PB and J, but like deadly sandwich. So I don't know how they dissociated it, but they did, and so
Okay,
they
now
did.
I'm gonna remember that.
Yeah. So I mean, whatever. If it typically the stupider it is, the more I remember. But don't write like jelly on like the quiz.
It
Okay.
was
So if
Chase
you're thinking
Dalton, wasn't it?
what?
Chase Dalton.
I think it was actually might have been Lydia's class that came up at first, and then I told Chase and Dalton, and so once I told them, they're like, "Oh yeah, no, we got it now." But it's just one of those.
Now we got
It
it.
makes perfect sense.
Yeah, this one as long as
You
you're
got
supposed
this.
to remember. Right. What's the other way? Sodium.
And I. No. Sodium.
Sodium.
And I.
Nope. That's nickel.
S-A.
What?
S-A.
No.
No, wait,
I-
sodium. Sodium?
Yes, sodium.
He said what? He said Ni?
You said
Yeah.
N-A?
That's why I knew it. I knew
A.
it. I knew it. Not available.
Alright.
Number 23.
Bring.
Yep.
I thought so.
Alright. Chromium.
It doesn't start with C, does it?
It does start with C.
C-R?
CR.
I thought so. You got it.
Why?
Nine.
It's not. It's not.
9. Major. Alright. Lithium.
Wait, what?
Lithium.
Lithium?
Lithium.
Li.
Li.
You lie.
Let's see. 32.
32.
It's 32.
Alright.
16 times 2.
Gold.
AU.
AU.
It's 36. That's good.
29.
9.
I'm guessing 36.
Alright. Silver.
Silver is HG. No, it's not. It's. Let's start with.
I know.
Silver is Mg. No, it's not. Silver is HG.
HG. That's mercury.
Start with that? Is it S?
No, it's
No.
not. It's not. Just.
S.
Nope. AG. So you have already have a G, but AG. Alright. Plutonium.
Plutonium.
So almost said
PL.
plutonium. What?
PL.
PL?
P. Yeah.
Nope.
Q.
PU. Plutonium. Alright.
Stinky. 36.
No. 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 I was gonna say that.
Alright, I think we might have time for one more quick one. So I'm gonna finish the cards and we'll go over the hard ones
I
again.
ended up with like 6 jobs.
Bruh.
Yeah, block. At least this game we're moving a lot faster.
Watch me get this last one.
Real quick. No, we need to even it out. 2 and
Yeah, I had like a bunch of lifesavers wrong.
We'll try it there. Know that.
I'm.
She put it on 27.
Yeah, she put it on
She put it on 6.
Alright, we'll let Ethan start. Alright, Bromine.
Bromine. BR.
BR.
BR. 636.
Sure.
No. Number 1.
Alright, iron. Iron.
FE?
Sure.
36.
Please no. Please no. I'm about to say.
Alright, potassium.
Potassium.
Bananas.
I know. PT.
Nope.
Is it P? No. Start with P. Does it start with P?
Makes it harder.
K. K.
Okay.
K. Alright,
SN.
Good job.
18.
I don't know.
Alright. Strontium.
Oh, this is the hard one.
Is it?
Start with an F. Is it an S? Is it an
Yes.
S?
Just S?
Yes.
Nope.
Oh, I know. I always know it right after I guess it.
SR.
Yes.
27.
Alright. Sulfur.
S.
This one is S.
6.
No.
Alright. Cesium.
I know where it is.
Cesium? How did I spell that? SE.
I forgot what I had. Yeah. No.
No, I was.
No, I already answered.
CS.
Yes.
32.
Alright. Phosphorus.
BH. Nope. BH. Nope. Phosphorus doesn't start with a P?
Maybe.
You told him yes.
Okay, yes, then. Yes. And that's it. No more hope.
Phosphorus. PS.
Nope.
PH.
Oh, nope.
Did I say that?
Nope,
Is it
nope,
P? Is it
nope,
P? Is it
nope,
P? Is
nope,
it P?
nope.
Is it
I was
P?
thinking of something else. I asked for phosphorus. Phosphorus is not PS or PH.
P.
Yes, it is just P.
31.
My dyslexia occasionally. Alright, radon.
RA.
No.
Radion.
No, just radon. You're thinking of radium, so radon.
RN? Wait, he gets RA then. Is it, RA?
Nope, RN. Radon.
Yeah, I know. As soon as I said I knew.
Alright, hydrogen.
H.
Yep. Yeah, let's go over the hard ones. The ones on this.
29.
He didn't get it.
Yeah, I did.
Oh, hydrogen was the last card. And then I said we're gonna go over the harder ones. Alright, platinum.
PT.
Got PT.
13. I bet you it's 26. Guess
Alright.
26.
Radon.
RN.
RN.
Just 26. You were.
26.
Also,
I thought, see, that's why I did it. That's why I
That's
told
so
you.
mean, Chris. Alright, potassium.
I thought she was gonna put it back on there.
I have done that.
Okay.
Yes.
4.
14.
So 4.
Yes.
Silver.
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 AG.
AG.
17.
OG.
Come on.
Alright.
This is gonna be a third.
Phosphorus.
This is just lucky.
That's P.
21.
It's dead on my okay.
Sodium.
Sodium. S. No.
Wrong.
That's sulfur.
NA.
Na for sodium.
9.
9.
Lead. That's the last one.
Alright, if I get it this time, I'm gonna freak out.
Nope.
You have to choose eventually.
11.
That's, no, do not. No.
No. Let me go 15.
Final answer?
Yes. Was it 11?
I'm not telling you. Alright, I will let you both get 2 more guesses, so we'll alternate back and forth. If you can't find it in that, then the game's just done. Alright, so 2 guesses.
2 more.
Yeah, okay. Pick one, and then Chris, and then pick one, and then Chris. Okay.
Oh, okay.
Pick one.
19.
Sure.
Yeah.
Alright, Chris.
11.
Sure.
Yes.
Good job. Alright.
I almost guessed from the last
That's my
one.
lucky number too.
Alright, go ahead and take out your chemistry book. We gotta
You
go.
better give me.
Alright, now keep in mind, have you had a quiz yet in chemistry over? Review material.
Nah, who cares?
No, we probably have one tomorrow.
If tomorrow's
We said probably for a week, so probably.
Well, tomorrow's Thursday, so we probably have to review quiz
And
tomorrow.
today was Wednesday.
Wednesday.
Yeah, but so
Alright, so if you have your review quiz tomorrow, make sure you're studying on the focusing on the periodic tables because that's typically how we want to make sure you've been studying over it. If you don't have it tomorrow, what day will it be, Chris?
Friday.
Your name's not Chris.
It'd probably actually be Monday because we're having the element table.
Why can't you have 2 quizzes on Friday?
We've never had one.
Yes.
Yes, you can. I've given 3 quizzes in one. No, I think it might have been. Yeah, it was 3 quizzes, 3 quiz stuff in one class.
Who were the 4 victims?
It was history because it had to do a reading quiz, editorials, and a review quiz on the same day.
Did you feel bad?
I felt slightly bad, but because of I forget
Torture.
Did they do
I forget
good?
like what happened, but it was where like they all had to fall on that day, and it was just one of those. Okay, study this right
Like
now.
4 breakers.
Study this right here, right now. Okay, go. Okay, here we're going.
Did they
Okay,
do good?
editorials, go. Okay, review, quiz. Okay, bye. That was pretty much the whole class period at that point.
Joking.
It was pretty much the whole thing. It
Did
was
they do
bad.
good?
Decent. Okay, but thinking back
That's
over
not
it,
decent.
what's the
95
difference
minutes.
between you have a physical change and a chemical change? What's the major differences between those two? Alright,
chemical
child,
change and
Ethan,
physical
sorry.
change. The chemical change
Yeah.
changes basically.
Okay,
It's-
from, is it just how it looks or the change from one whole substance to another whole substance?
That.
Is it how it looks? Like crumpled up piece of paper, or is it changing from like paper to ash?
That. Paper that.
Paper to
the
ash,
ash.
so it's a chemical change from one
Yeah.
substance to another.
On the
Alright, how do you know a chemical changes occur? There's a list of 4 things, name one.
Can I name off one?
Oh, sure, if you want to.
It emits gas.
Good job.
So bubbling.
Alright, that's the same idea as gas. Okay.
Significant change in color. Is one of them like it emits a smell, right?
That's probably more of a gas.
Okay. Is it
What do you call it whenever like you mix stuff together and if you touch the beaker it feels warmer? Like what would that be?
temperature change.
Okay, liberation or absorption of heat, light, or some other form of energy. This is why whenever you crack the glow stick and shake it up, it now starts to glow because the chemicals on the inside.
And,
That's the last one.
Is it like their actually changes the like actual element itself, like it changes?
Well, how do you know? Like these are how do you know what chemical changes?
It changes the chemical I forget the word, the chemical
Property?
properties.
Well, these are according to how do you know a chemical change has occurred. So what's it called whenever I mix 2 liquids together and you see like the salt grains like start to form, like it looks kind of like dust or salt in the bottom. What do we call those solid particles that come out?
Fusion?
Nope. Do you remember?
Precipitate.
Precipitate. So, or precipitate is how it looks. Alright, what do we call it whenever you can separate homogeneous mixtures by basically boiling them apart in a special containers? What do we call that? Do you remember?
Containers called?
It's the something process, or it's by this. That's how they say it.
By fusion?
Not diffusion, just starts with D though.
A pink cookie fusion.
No. Alright, distillation. Make a note. Distillate. You're thinking of
I
the.
just thought we said pink cookie.
Yeah, you're thinking of the film pudding model, Chris. So, I'm not
Thinking of
Chris.
the what?
Even. So, alright, distillation is whenever like you put them in the containers and they separate out their boiling points. What is it called whenever you mix the chemical with a solvent and it goes at the paper and separates out into its colors? What do we call that?
I remember now. Is it like what's start with G?
Starts with C.
Color change paper.
Nope.
Formation.
Nope. It means color writing is what it means based on like its.
Is there a G in it?
There is a G in it.
Like is there a G in the beginning of a word of the title?
No.
Is it 2 words?
Nope.
Is it looking?
That's close, but not quite. So chromatography.
Chromatography.
Is there any note of that as well from it? Alright. What part of the atom is a negatively charged part? We've gone over this loosely yesterday.
Electron.
Electrons. Let's see, what are cathode rays made of? They discovered.
Ooh, I don't know what they're made of. I know. Wait, is it protons?
Protons, neutrons, or electrons? Which one? 1 in
Protons.
3 chances of guessing correctly.
Protons.
Cathode rays.
Neutrons.
Cathode rays.
Electrons.
Good job. So, remember cathode rays were used, or the Crookes tube was used to discover electrons.
I think that's the other rays. What are the other rays?
Canal rays.
Canal rays.
Canal
Yeah.
rays.
That was protons, right?
That is protons. Alright, who came up with the oil drop experiment? Who's the guy? So he basically used the X-rays and the oil to figure out what was the mass and the charge.
Did we make a pink cookie thing?
Nope.
Then let's start with
His last name begins with an M.
massacre.
Nope. Alright, Chris, you know? Cheater.
No, I'm not
Okay.
cheating, I'm not cheating, I'm not cheating.
He's just helping himself.
I'm just trying to, give myself a better,
Alright.
I need to see one more second.
One.
You said it starts with an M?
Robert Milliken.
Robert Milliken.
Robert
Milliken, I knew it. I knew it.
Milliken?
Milliken, but it's spelled funky, so
I just put Milliken.
M-I-L-I-K-A-N. Robert
Yeah.
Milliken.
Millie can.
Remember? That's fine. Alright, who came up with the crook? Never mind. Crook's tube, so William Crooks. Alright, who came up with the plum pudding model? Alright, Ethan.
What's his name start with?
His last name starts with a T.
It's literally the most, white American name ever.
Timothy?
No.
Tom?
Yeah, J.J. Thompson.
Oh.
Alright, who came up with the planetary model?
What's his name start with?
R.
Robinson.
Hmm.
Robertson.
Nope. Alright.
Ringingham.
Nope, this is not even close to this. Alright.
Ringham.
Alright, Chris,
Where'd you guys again?
who came up with the planetary model?
I remember looking at
Oh, the planetary Rutherford.
You're doing Rutherford. But yeah.
No.
Rutherford is the
It's
model.
not even on this page.
Alright, what? Let's see. Alright. Oh, what is the neutral part of an atom called?
Neutron. Nucleon. Nucleon.
Go back to your first answer.
What?
Go back to your first answer.
Oh, neutron.
Neutron. So, of the three different parts. Proton's positive, neutron's neutral, and the electron is negative. So, make sure that you know that. Which two are in the center of an atom?
Neutron and proton.
Good job.
I was about to say
Alright. Oh, what do we think protons and neutrons are made of?
Quarks.
Quarks. Good job.
You
And then what determines, don't get too distracted, Chris.
Yeah.
What determines the identity of the element? The number of what?
Number of protons.
Protons. Alright, go ahead and look in your textbook on page number 31 is where we left off talking about protons, neutrons, and electrons and the importance of them. Now, there's a lot of them on this page that are very, very, very similar to each other. So be very, very careful because you don't want to get them accidentally
That's
mixed
why I
up.
made 70.
Alright, what?
That's why I made 70 yesterday.
Okay. Study. But yeah, it is hard. This section is a rough one. So atomic number, identity of the element. So the number of protons determines it. So Jamie and Quentin, you can't see my graph table, I'm sorry. But if you want to use the one in the back of your book, you can open up your book and look at the back cover of yours. Yours also has the correct table. So if you're looking over here at iodine, how many protons does it have? Can you read from over here?
53.
Good job. What if I were to take away one proton? Will I still have iodine? What am I pointing at? Iodine.
9.
What will I have? What's the other one?
T.
Te or
Carrier.
Yep. So tellurium. But yes, you would have C2
Oh.
protons. Not
I can't read it from over here, actually.
I know. It's okay. You did a good shot. What if I were to add a proton, Ethan? Would I still have iodine?
No!
What do I have?
Xeon!
Good job. So that's the idea. You cannot change the number of protons. The number of protons is die hard. Every single one of them has that same number of protons.
If
Okay.
you asked me, I would have said yes, because I thought you were asking me what if you added one to T.
Yeah, I realized it after I said that I would take that answer and then I would re-explain it to make sure I got the correct answer later on. So that's one of those, once the words came out, I was like, yeah, I'm probably gonna get two answers, but I'll fix it. Alright, we use the symbol Z to represent it. So in your formulas, whenever they have Z, they mean atomic number for right now. So just pay attention that that's the symbol for it. Alright, so make a note for that. Mass number, this is the number of nucleons. Alright, Ethan, you were saying nucleons earlier. What is a nucleon?
A neutral?
Okay, you're thinking of neutron. This is nucleon.
So, protons and neutrons?
Yeah, it's basically talking about both of them together. You're talking about the center of the atom. So instead of saying protons and neutrons, protons and neutrons, protons and neutrons, scientists just said, okay, mush them together, nucleons. Kind of how like sometimes whenever you see a boyfriend girlfriend couple, they might refer to themselves as like their names hooked up together as like that hyphen name kind of idea, just saying that they're together. Okay, kind of like the same idea. So nuclear particles is whenever you have protons or neutrons, they're known together as nucleons. So this is the number of protons and neutrons together. We use the symbol A for this. I forget where they put it around it for it. But it's the idea for they put it above it. Typically when we're talking about it, it's a number of protons and neutrons together. Now, your book gives you a formula to help you figure out the number of neutrons. So it says that if this is the total number of protons and neutrons together, and I need to find just the number of neutrons, and I know the number of protons, what can I do to figure it out? So let's say I have a sample of carbon, and I know it has a mass number of 14. And how many protons does carbon always have? You don't have to memorize this. I do because I work with carbon so much, but you don't have to memorize it. So how many protons are always in carbon?
14.
This is mass number. Look at the periodic table. How many protons are always in
6.
carbon? 6. So if I know there's a total of protons and neutrons together, and carbon has to have 6, how many neutrons are there? How do I figure this out? Algebraically.
8.
How'd you figure it out?
Right, subtract.
Yeah, so you could either do it as, okay, 6 plus something equals 14, or you could say, okay, 14 minus 6 equals 8. That's what the formula is showing you at the top of the page with the idea of A equals Z plus N. N means number of protons. We're not going to go through and practice that because that's simple algebra. But it's basically, okay, if I know the mass number, because the number of protons does not change per element, you can use your periodic table to figure this out. You can find the number of neutrons from it. And then also, if I'm giving you the number of neutrons and the number of protons, you can add them up and find what's the total number of nucleons. But we're not going to practice just by itself this, just because it's simple algebra. Okay. What?
So wait, it's commutative though, since you could do A equals or Z equals A plus N or A minus N or whatever defined.
Yeah, basically you can use it to find any of the other values. So you can basically take this column and reshift it to get whatever you need to find your last variable. And so that's why we're not practice it right now, because it's simple algebra. We're just gonna move on from it. Alright, so just figure out the mass number is not really mass, it's a loose approximation, because we're not talking about the number of electrons, but the number of electrons are so small that they don't really matter. Just figure out though, we're talking about this is a whole number. How many whole numbers of protons and neutrons do I have? You can't have half a proton. So become that they're a whole number, and it's an approximate over how much they weigh. It's pretty close most of the time. This is just an approximate number. Alright, isotopes. This is an element with different number of neutrons. Alright, so if I have carbon, I've got that moving chalk. If I have carbon, I'm just going to carbon off the thing. How many protons do I always have?
You said 8, right?
Okay, that was the number of neutrons over there. Number of protons. So 6.
Is that actually true?
Yeah. That's one reason, that's how come they put it on the periodic table. Because all of these, that's one reason, if you look at, you'll notice that they're in numerical order of the number of protons. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's the reason why they do that, is because they say, okay, here's the increasing number of. There's also other trends as to why we make it look like this. We'll talk about it later on. That's the reason why that they're in order. Now, if it's a little bit funky down here, they jump down. There's a reason, because they don't want the table to be super long.
14 actual.
But they're going, but they will. We'll talk about more later on. Ethan had a question, and then you. Okay. So what
What's
question?
the 3 through 12 on the numbers?
Say it one more time.
The numbers 3 through 12. Yeah. Like on top of,
These.
yeah, like what goes down to the other side. Like 1 through 3 through 12.
Three.
Yeah,
What are
you know-
these? What are these?
Yeah.
Okay. This graph table is newer. I'll try to slide it over tomorrow, Jamie, questions that way you can see it. But there are 2 ways to talk about the different columns for the up and down portions of a periodic table. I memorized it with the red letters. Whenever I was back in high school, we used an older system where this was 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A, or 0 is another way to do it. And then these were the B's, so 3B, 4B, 5B, 6B. So I memorized it that way. Occasionally, you'll hear me say 3A, because that's just how I learned it. Your book goes off the more modern version, and that's how they have it listed as well in the black. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 18. That's the modern way of doing it. We'll talk about the reasons why they do it, but occasionally you'll hear me say 8A or 0 or 5A. That's because it's how I learned it, and occasionally I'll forget and I'll use the old way as to how I use it. But they're labeling these up and down columns And there is certain trends to where a lot of these columns are very similar to each other. Like, you might remember the noble gases. These all have similar properties to each other. And we'll talk about the reasons why once we get there. But yeah, that's why things really have those numbers on them. Alright, so isotopes. Back to this. So this is an element with a different number of neutrons. So carbon always has
8, 6.
6. You don't have to memorize it, but look at the periodic table if you don't know. So carbon always has 6. Now, if I were to have carbon that has a mass number of 14, okay, how many neutrons is that? I'm sorry, what's your question?
Two things. Is 14 the actual atomic number?
A mass number? It can be.
Okay.
There can be really be a carbon
Can it be
14.
anything?
What?
So it can be anything? It can be carbon
A mass
14.
number basically says how many protons and neutrons you can have together. You can't have, let's see. You can't have, nope, it's that one. Let's see. You can't have this, because how many protons does oxygen always have?
No.
You can look at the table, it's fine. How many protons? I also wrote it.
7, 8.
Okay, now remember, mass number, I'm sorry, atomic number is written down here, we'll talk about this in a little bit, but it's written down here at the bottom portion of it. So it always has 8 protons, so it cannot have a mass number of protons and neutrons together less than that.
Are you gonna make us memorize that entire word?
No. Like, you will have to memorize different parts of it, but you don't have to memorize which, like, number of protons goes with which one. You'll gradually catch on and figure it out. Like, hydrogen always has 1, so you'll memorize hydrogen. You probably memorize carbon, because carbon always has 6, and you work with carbon a bunch. You probably memorize oxygen,
You
but
memorize
I don't,
carbon knowledge.
I memorize where the elements were on the table, like, which columns they were in, and the names for them. And I think it was pretty much the entire table. But again, alone, like, scientists, they don't have to do that. You need to know the symbols of the elements right now, and you'll eventually come on that, okay, here's the ones in the major groups, but I'm not gonna ask you, like, where is this one and how many protons does it have? If I do, I'll give you a chart to help you figure it out, so that way I know that you know what the different numbers mean. Alright, so, to get back to your question, if oxygen has to have 8 protons, can it have a mass number, which means number of total protons and neutrons together? Can it be less than 8 then? No. So, you can have a number greater than that. You can have like 9, be to where you have 8 protons and 1 neutron. But, so you can't have any number be with any number, be the mass number? No. The mass number has to always be equal or at least greater than the atomic number. Okay, did you have a part 2 question? Was that it? Alright, so getting back to it with isotopes, so if I have carbon which has 6 protons, but it has a mass number of 14, how many neutrons does this particular carbon have? 8, right off the side. Another version of carbon is this, to where you have how many protons, Chris?
6.
Because you always have 6, and then how many neutrons are on this one?
6.
Yeah, so it's just simple math at this point. Alright, these are both carbon because they both have the 6 protons. So it's automatically carbon. We call it though, whenever some of them have more neutrons than others, we call them isotopes. So that's what it's talking about, element with a different number of neutrons. Because they both have the same number of protons, they're not jumping elements, they're not changing. Just one of them is heavier than the other. And this does happen. We see this out in nature. Some of them just have more neutrons in the middle. Now keep in mind, does the neutron change the charge? No, because it's neutral. It's basically just extra heavy stuff on the inside of it. And it's okay, it's still carbon, it's just a slightly heavier version. Alright, anyone have any question about an isotope? Alright, your book tells you how we draw them, so that's the reason why I've been writing them this way. One version you can draw them is they will use the X to represent an element. Atomic number goes on the bottom, mass number goes on the top. So like I was just drawing it, carbon, 6 on the bottom, 14 or whatever is on the top. Or if you're doing oxygen, oxygen has how many protons? You don't have to memorize, you look at the table. So how many protons? 8. 8. And we'll say this is oxygen, 17. Alright, but it's the idea of oxygen, the atomic number goes on the bottom, the mass number goes on the top. Your book gives you the example of X just representing any element. It doesn't mean xenon. So it's just saying any element or X. Remember, xenon is Xe. So just make a note for that. Your book gives you an example with lead. Alright, so lead has what atomic symbol as a side note? Chris.
Oh,
Deadly sandwich.
PB.
Alright, so PB. I don't know why I wrote it backwards. Alright, So lead has 82 protons. Now let's say it says 206 neutrons. Alright, so if it has 82 protons and 206 mass number, how many neutrons does it have? You're gonna do math really quick. Not 100 oh wait, not 104.
34.
Not 130.
134, sorry.
Not 134. You're close.
124.
124. So 124 for the number of neutrons. Alright, so your book points out, so in some cases they will write it after them. Your book gives you the lead version for this one. So you could write it for this one, 206. You might write it out with lead 206. Typically, whenever I do it, this is the version I use where I'm saying this is the lead, but it's this mass number, it's this particular isotope. You can also have this version of lead as well, to where you can have it to where it might have 4 more neutrons than normal. And these are both 2 versions of lead. Now, they're both lead, so how many protons do they have? 82. So it's just the number of neutrons has changed. So this first one has 124. The second one has 128. But they're both still lead, just they just have a different number of neutrons. A more common version is with carbon 12 and carbon 14. That's how come I've been using that one. So carbon 12, they'll just draw it like, sorry, I said carbon 12. Carbon 14 or carbon 12. These are 2 versions of carbon. So carbon has how many protons, Ethan?
6.
6. So this one has 8 neutrons, this one has 6 neutrons, but they're both still carbon. So these are also 2 real versions or isotopes of carbon. Sometimes I'll write them like this, sometimes I'll write them out fully for it. This is the way I use typically, so if when I'm writing them on the board, this is the versions I use because it's the easiest for me. Alright, anyone have any questions about this? Alright, an ion has a different number of electrons. Alright, so the electrons are what part of the atom? Positive, negative, or neutral? Negative. So if I were to gain electrons, what would be the charge of my substance? Ethan?
And electrons? Huh?
Yeah, if I gain any electrons.
Ion?
Okay, it is an ion, but will it be positive or negative? Let me add a more negative jump to it.
Positive. Yeah.
Yeah, more
Yes, if I add more negative to it,
Oh, I
so,
thought it said positive for a second. That's why I
Okay.
said that.
yeah, negative. So what if I were to lose electrons? It is positive. Now, going back to carbon, because carbon's easy. Alright, carbon, it has 6 protons. We'll say this is carbon 12. So carbon has 6 neutrons for this one as well. Okay, so if I have 6 protons and this carbon is neutral, how many electrons do I have to have?
It's 3, 6.
6, because if I have 6 protons, that means I have a positive 6 charge. If I'm going to have a neutral or a 0 charge, that means I have to have a negative 6. So how many electrons?
6.
6. What if I were to have, we'll say carbon 14? How many, let's see, how many electrons do I have to have if it's going to be a neutral charge?
Negative 8 charge?
What?
Negative 8 charge?
Negative 8? Well, how many positive charge do I have?
Positive 6.
Positive 6. So if I have to have a neutral charge, how many electrons do I have to have?
2. Negative.
So if I add on, so how many how many protons do I have?
6.
6. If I'm going to have a neutral to where a positive 6 plus something equals 0, what do I have to do to get it balanced out?
6.
No, you gotta give them a chance to finish it. Thinking of 0. What?
6.
So negative 6 charge. All right. So each electron is a negative 1. So how many electrons do I need?
2. Wait, what?
Two.
What?
Okay. How many total electrons do I need to get a neutral charge if I'm going to have 6 protons?
6.
All right. Yeah. So does the number of neutrons matter at all? No. That's the main reason why I was asking this one. So don't worry about does the mass number change, because this number.
So if they're asking for electrons, it's 6.
Oh no. If you're asking for carbon, because carbon has 6 protons,
Yeah.
if you're going to have a neutral substance, it's always going to be 6 for carbon, because each proton is a positive 1, and each electron is a negative 1. So if you have a neutral substance, they have to balance out or cancel out each other. Does that make sense?
Yeah, kind of.
Okay, we'll work more on it. Okay. So does that answer your question? Yeah, but basically,
Couldn't you add, couldn't you add an extra proton and add another, or
that's a good question. If I add a proton, though, won't you have carbon?
Oh, no, you won't. You
No.
have
So that's why for ions, we're talking about electrons specifically. All right, you don't have any homework this Wednesday. We'll practice with this tomorrow.
Or cherries.
Is there an orange one?
I think Ethan stole all my oranges like last week. He got them all.